Ice Harbor RSW actually started prior, many years. There was a lot of work being done at Ice Harbor Dam testing the ice and trash sluiceway, where they released a small amount of water and they did biological tests to see how fish were attracted to that. And that was really kind of a genesis moment of realizing lots of fish use that surface route. And then we got together a team of people called the Surface Bypass and Collection Team, several biologists with Walla Walla District, hydraulic engineers, project manager, myself, and worked through a process to try to implement that somewhere. That team then realized that Lower Granite was probably the place to test it. Lower Granite had millions of juvenile fish that pass at that project, so it was a key place to find out really on a large scale what that system might do. So the next step was design and installation of the surface bypass collector. It was a large steel box in front of half of the powerhouse at Lower Granite, and they had different depths of entrances and different flow arrangements so that they could test whether fish like to enter at a high opening near to the surface or deep openings or combinations depending on species. That structure went through rigorous testing over many years, and at the end of it in about 1998 it was determined that surface passage routes were really where most of the fish traveled anyway, and that they would readily go into those entrances and pass. The problem was we couldn't at that time find a place in a spillway where you could implement that, because the spillways are designed strictly for flood passage. So if you put a structure in a spillway, you've taken away some flood capacity of the dam. And working through that and lots of discussions. In fact, we brought on an AE, Jacobs Civil Incorporated out of the Seattle area. And one of their engineers said, well, why don't we put a structure in a spillway and just make it removable? So that was the aha moment, I think, where we said, maybe we can do that, and went through, a few brainstorming sessions and came up with an idea of being able to tilt the structure out of the spillway and essentially evacuate that spillway and be able to turn it back into a flood control structure. So that was the removable part of removable Spillway Weir. In a lot of ways, it's not the significant part of it because it's a fish passage structure. It's designed to make a dam as invisible as possible for fish as they're migrating downstream. They encounter a dam without a surface route, there's a lot of delay. There's a lot of opportunity for predators to prey on them. If they can find a route quickly past the dam, then that minimizes that to a great deal. So that's the main function of a removable spillway weir, and the removable part is really only in a major flood event. So it's less significant, but a very necessary function. After the testing of the surface bypass collector, we aggressively moved into designing a prototype at Lower Granite Dam. We started in 1999. If you recall, at about that time frame, there was a lot of political pressure. The 4 Lower Snake River dams were, considered a major impediment for fish, and so even at that time there was much discussion about removing the dams, less so probably than there is today. So we had a BIOP that said that we needed to get systems in there to make passage better for juvenile fish. So really in an 18-month period of time, we went from an idea of how we could install a structure at Lower Granite Dam, went through really a lot of modeling very quickly at both our ERDIC labs in Mississippi and also ENSER labs in the Redmond, Washington area. And we came up with a concept, came up with what we thought was a way that we could remove it in a flood event, and then designed it and constructed it in about 18 months. So it was a pretty busy time for the Walla Walla engineers and also the AE team that we had on board. So that structure is truly a prototype. It was concept to construction in 18 months. That took it to about the year mid-summer of 2001, excuse me. So the first day we operated it was 9/11/01. So the same day as 9/11 was the day that we were scrambling to actually test it and open up the gates for flow at that time. So it was a memorable event for me twice because of the tragic events in New York, but also kind of the anxiety and thrill, I guess, of opening those spillway gates and watching flow go over the fish slide really for the first time. Went through a couple years of testing of that structure, and pretty quickly we realized it was working very well. We were getting a high percentage of fish using it, and with really high survival as well. Fishery agencies really, were on board with it because we were able to really accentuate what spillways were doing for fish passage by putting a higher number of fish through the spillway. And so I think a lot of people jumped on board, and the next question was, how fast can we implement elsewhere? And the next site was for really the first generation RSW was at Ice Harbor in 2004. And I don't remember if we were operational in 2004, but right around there, 2004, 2005 was when we installed that one. And the major engineering change there was we went from a fairly rudimentary removal system at Lower Granite. It was essentially a diving bell, where the air inside the RSW at Lower Granite is like taking a diving bell, turning it upside down, and capturing air in it. Well, as you take that bell and put it to depth, your buoyancy decreases because pressure increases and your bubble gets smaller. And the smaller the bubble that you've trapped there, the less buoyancy you have. So actually at Lower Granite, that structure, as it's deployed upstream for removal, it wants to accelerate to the bottom. And then there's the physics of figuring that out and having to actually add air to arrest its descent. And that was very, very, very difficult engineering problem. So at Ice Harbor, that second generation structure, it's more like a submarine. We have a certain amount of buoyancy with hard tanks, and we just add water as ballast to change its descent down. So it really operates just like a submarine, and that was probably an aha moment for the engineers working on it, and made the controlled descent part of that much more feasible, much more safe, much more reliable. So that structure went through testing. Again, high survival, high use by juvenile fish. They did have some issues with the crest itself at Ice Harbor. There was some fish injury there that has since been mitigated by changing the crest angle as the water comes off the RSW. So it's been in operation for 10 years, and with some minor modifications, it's working very well. And I believe after that, the next site we moved to kind of concurrently with McNary and Little Goose Dam was Low Mo. So we were working on essentially the same design as Ice Harbor at Low Mo, and had that under construction in the 2007-8 time frame. At McNary, we were testing what were called temporary spillway weirs, and they were weirs that went into the spillway, but they acted a little bit differently. They were more like a controlled waterfall, where flow would come over the weir, detach from the weir, and then reattach at the crest. So it was like more like a waterfall, where the prior RSWs were more like a water slide. All that water was supported all the way to the concrete. What we found out, though, that even having detached flow and acting more like a waterfall for fish, survival again was very high. It wasn't a, it didn't turn out to be a big problem for fish. And that concept was carried to Little Goose, where we did very much the same thing at Little Goose. We had a topspill weir there as well. The name kind of changed from temporary to topspill when we began using it at other sites. All three of those projects were happening about the same time, so we were trying to implement all the way through the Lower Snake and McNary about the same time. When we completed at least the topspill weirs at Little Goose, that was essentially completing that system for the snake. Since then, we are now looking at the second generation of weirs, recognizing that Lower Granite went in 2001. Those structures are designed to be about 20-year life. They're steel structures that don't have an infinite life. They have piping and steel and coatings and all sorts of things that do corrode. So at Little Goose, fairly soon, 2016, 2017, we will be installing an adjustable spillway weir there. Just the next evolution of this concept and this technology. The difference at Goose is the weir can be changed for summer and spring operations. We can change how much flow goes over it, whereas the other structures essentially are one flow range. Depending on forebay, you get one flow. So fish agencies and our biologists were interested in seeing if we could alter that flow to kind of fine-tune it for different seasons, and that's going to be the next test in a couple years. I anticipate it's going to work well and would be, as some of these prior systems become, not as reliable, that we may end up removing the large structures, which, typically an RSW is 115 feet tall, 84 feet wide around there, 70 some feet in depth from upstream, downstream direction, weighing a couple million pounds. Those are very big, very complex, very expensive structures. The adjustable spillway weir we anticipate is, maybe more in a $5 million range. So being able to change those out with that high first expense, but still be able to give us a function is what we're really after in the end, and also the added benefit of the flexibility and flow that those can provide. So that's really kind of walking through the whole progression of removable spillway weirs, temporary spillway weirs, top spillway weirs, adjustable spillway weirs, throughout the system, at least for the Walla Walla District. I should say some of those same technologies have been implemented on the Lower Columbia as well through Portland District. So there's essentially, through the 8 federal dams, we have a method for juvenile fish to pass at the surface level at all those dams at this point in time. Initially, the biggest challenge we faced was time. When we were doing these initial weirs at Lower Granite and Ice Harbor, we were under a lot of pressure to meet the biop requirements on the time frames they gave us, which were, they had hard dates in the biop, and so they really drove us to implement some of these probably faster than we should have, maybe looking in hindsight, but it did accelerate everything, the technology, and it put people into a real collaborative mode because of the time frames. So it was good and bad. Some of the technology had to catch up as we worked on that, but time was not on our side, so we really worked hard to get those done in time and meet the biop requirements. Its number one function is to allow juvenile fish, as they out-migrate to the ocean, to move through the river system and encounter a dam that they can readily find a route to get past that dam. And without delay, without having to search, without having to dive very deep, these fish can get through these projects. a high percentage of the fish are passing these dams with really a relatively small percentage of the river flow. So it's a route that they find. We've reduced delay by a day in some cases, so significant reduction in delay. Those benefits are reduced predation and really reduced stress for the fish. They can just move on through the whole system and get to the ocean when they want to get to the ocean, you know, as they travel down.